My name's Don Murray, and I'm here with Stuart Harper. Stuart leads our FME Cloud group at SAFE, and I'm just here as because I'm an enthusiast and have played around a little bit with AWS services, and I'm answering questions this morning. We have our true experts, the guy who have built FME Cloud on AWS. So thanks for joining us this morning, and we're going to go through some of the things we've learned as we've built FME Cloud and also worked with FME Cloud at SAFE, and we'll present a couple of patterns and things like that. So
a few demos.
Yeah. So do you want to take it away, Stuart?
Sure, yeah. So we've got Claude in the background. He's there, and he built FME Cloud actually. So, well, he built the Amazon side of it, so you can ask him some very hard technical questions.
Yeah.
Okay, so we've already done the introductions.
That's right.
Do you want to?
Sure, yeah. So just a little bit about who we are. At SAFE, we essentially build a data fusion engine, the ability to move data from anything and move it anywhere. And we started on the desktop, moved to the enterprise, and then now we've moved to the cloud. We talk about connect, transform, and automate, and the connect is this ability to connect to virtually any data source, whether it be a file, a database, an application, a web service, a sensor. And once you've connected to this data, of course, as we can move data or fuse data together, we talk about transformation, and that's really the power of the engine that is FME. So the connect part enables data to get into our system, but really this ability for you to do with the data as you want is really what we're all about. And of course, everything today is about automation. When we started, files would be updated, yearly or monthly, and with databases they were updated, periodically. Now we're seeing more and more the amount of time between when data is created to when it's used is becoming less and less, to the point of real-time data even. So now that's really where automation is. And FME and server and FME cloud are all about how can you build these workflows and automate them. So
agility and responsiveness. That's good. Okay. So there's a lot going on in Amazon. I think there's over 50 services now. We were at reInvent last week, and there's just
and they announced even more.
Even more. And there's every business sector. So we're going to focus on the data side more. So initially we're going to talk about the simple storage service and RDS and Aurora. A few other data storage services, DynamoDB and Redshift. We won't really talk about those too much, maybe a little bit about Dynamo. Our customers haven't really used them as much as these two services, so we'll focus on these two primarily.
Sounds good.
So S3, for those that are not familiar with it, it's Amazon's simple storage service, so I think it's one of their first services. So it's basically secure, durable, highly scalable object storage. You can see all the figures and facts on the right. It's very reliable, it's very performant, and it's very cheap. I think that's how you can sum it up, really. It's really, most people use it for storing file-based data sets, don't they? So videos, photos, you could use raster data. Dropbox use it as their underlying storage service for their service, I believe, or they used to at least. So how it works, every object that you put into S3 is identified with a key. And it does look like a file-based storage system. That's how it's presented to you. But it's actually a key value persistent object store.
And it's actually much more powerful. So if you view S3 just as a file storage system, you're missing a large part of its power. And as Stuart said, really it's a key value store, and you don't even have to have a value. You can just check if the presence of a key, for example. And Stuart's going to talk a little bit about why this is important and other things you can do with S3. But when you look at S3, we encourage you to look at it not just as a place to store files, but as just remember this key value persistent object store, and then you can start to really understand the true power of S3.
You can store ones and zeros in there if you want, I guess.
Absolutely.
Okay, so there's a few other workflows and scenarios that I think you can use S3 for beyond just as a data store basically. So these are kind of when you might want to think about using S3. The first is if you've got all of your data on premises and you're running out of space or it's costing you a lot of money, or you just want to move your data so IT doesn't own it and you have control over the security and permissions, everything on your data, that's a good time to start thinking about using S3. If you want to start taking advantage of features that are not available on premises, so what have we got? We've got lifecycle management, versioning, encryption, data replication across how many regions? 5 regions or something like
crazy.
It's incredible how many times your data is essentially copied when you upload it to ensure stability. You know, there's a huge number of features you can't get.
Yeah, you can also anything on S3. You can also share it as a web endpoint as well.
Exactly,
so if you want to share your photos with your family, you could easily put them up there and share that too.
Very powerful. Yeah. If you're serving large amounts of data and you're having problems scaling, this is another issue. You know, that could be network scaling or just scaling disk.
Yeah.
You don't worry about it on S3.
No.
It just keeps going. Basically, the more you put up there, the more you pay. If you want programmatic access to the data, this is probably the biggest one for me.
Yeah.
Like you were saying, it turns every object into a URL, an endpoint, so you can access it via an API.
Yeah.
That's huge. I mean, how would you do that on premises?
So one obvious use is if you, let's say you had a lot of distributed components and you wanted them to share information, using this key value store of S3 is one component writes it to S3, others can read it, and they don't even have to worry about where they're located. They don't even have to know. It's like a whiteboard scratch area, so it's,
Yeah, great for integration. And the final one, which is a really kind of, I think people not too aware of this, is if you want to enable event-driven architecture, and we'll talk about a little bit about that later on.
Perfect.
So these are some of the tips and tricks that I think people are not aware of with S3 when I talk to them, our clients. So you can host a static website on S3 for nothing, essentially. I mean, basically you pay for traffic because the storage is going to be free.
Essentially free.
So we do this actually. So we have our GitHub repository and we have a branch on GitHub, and when we push to that branch on GitHub, our code repository, it automatically deploys to S3, and it takes a matter of minutes and all our code's up there. And so we don't have to worry about a web server. There's no Nginx, there's nothing. We just put our files up there and Amazon takes care of it, and it's stable and it's cheap. You can then hook CloudFront into that.
Yeah. So it's going back to that previous point. So what that means is I could have a relatively small web server. If I'm serving a lot of static data using S3, I can completely offload all of that off my web server.
Exactly.
And it'll scale, and I won't even have to worry about it.
Yeah. And if you want to take it to the next level, you should really think about turning CloudFront on. So CloudFront, most people use it kind of for content delivery network, but what it essentially does is when you enable it on an S3 bucket, it distributes that data and caches it all over the world at edge locations. So if you're in Tokyo and you access an HTML file or a piece of data, rather than going all the way across the Pacific to America to access that region, it just uses the edge location in Tokyo. So you get very, very fast, high level of performance. And again, it's minimal extra cost.
So S3 itself is fast. So you can view the CloudFront really as like a turbocharger.
It's
if you
crazy.
Even need, yeah.
And it's one click. Turn it on,
Yeah. And CloudFront, how much is that expensive?
I think it's free. I think you basically, maybe it's a minimal cost. It's to do with network traffic, if anything. I can't remember.
That is pretty cheap.
Yeah. Versioning is cool as well. You can have life cycle management on a file. So you could say, Don, if you upload a photo, you can basically tell it to automatically move it to Glacier after a set period of time and move that across to Glacier. And Glacier is a different service, and it's 4 times cheaper than S3.
Okay.
And it's basically for infrequent access.
Okay. And you can set up stuff to automatically move to Glacier?
Yes.
Okay.
Yeah.
And the versioning there, so I'm imagining what you're there is you can turn versioning on an S3 key, and as the value changes, you'll be able to go the previous
Exactly,
versions?
Yeah, it verges. So, and that's all just done by configuration on the bucket.
Wow.
So it's you can't get this on premises.
No,
it's not.
No.
It's just completely different.
Yeah.
The other thing you can do is if you want to provide a file out securely, so you say you want to send a file to someone, you can use pre-signed URLs to provide time-limited access to that file.
Okay.
So you can say, I'm going to give you this link, and it's valid for 2 hours, and then the link expires.
Wow.
So that's very powerful as well.
Yeah. Very nice.
Okay, so that's an overview of S3. People use it to replace FTPs often, or on-premises storage. Now we'll talk a little bit about RDS. This is Amazon's relational database service. And they added a new one, didn't they, last week?
Yeah, we were at reInvent last week, and they added Maria
I say Maria.
Maria DB, which is, for folks who aren't aware, it's a branch from MySQL. So it's, almost, our reader, we support both MySQL and MariaDB, but it's important that they have them both, because over time you could imagine they will drift apart. So yeah. So.
And the good thing about this database is when you think about moving to this, and we talk about these databases, that all have exactly the same interface as the on-premises one.
Yeah, and in fact with PostGIS, when they announced the PostgreSQL one with PostGIS support, we tried FME, and it just worked. And so we were, we were really pleased that was the case. We were able to enable all the spatial capabilities, and it just worked. So now internally at SAFE, often when we're putting things using FME Cloud, we often use RDS as our backend. It's really a best practice, isn't it? So if you're using FME Cloud or anything, RDS is so inexpensive. You put it there, it's automatically backed up, and the value is not just how it's scalable, but also as far as the management of your database, it essentially goes to zero.
It's it's great. It really is great.
Yeah.
So a few of the things that RDS gives you is essentially a platform as a service, isn't it? So they worry about all of the infrastructure, and these are hard problems they're solving. Automating backups, applying software patches, scaling storage, and scaling compute as well.
Yeah.
You can change the size.
Up or down.
You can replicate across multiple regions, and these are kind of all the key features that enable you to leverage the infrastructure they've provided. Okay, so we discussed this briefly. When you want to use RDS, and this is, I think, the main one is if you're a small team, you want to just bring a database up, it's perfect.
Yeah. And for prototyping, we found too, I mean, you often want to perform a database, like Stuart said, one click and away you go. And we've also found with FME Cloud by using RDS, that actually makes our FME Cloud instances faster, which means that because now the RDS is pushed off into other compute resources, so they're not competing, and so by many cases, if our FME Cloud is getting bogged down or whatever, we play around with the sizing of RDS too, and it can make a big difference.
It's big deal. Okay, so here's a rough costing based on an on-premises deployment for a RDS PostGIS database versus an on-premises database, and it's a big database, 16 cores, 122 gig of RAM. But you can see that it's a different scale. I mean, it's an order of magnitude higher on premises, and it doesn't include IT labor.
No, you just assumed IT labor was basically zero in both cases. And we know for a fact keeping hardware, we have our own server room, we know for a fact that keeping stuff running is not a zero cost game. So
exactly.
Now I'm surprised you didn't go for the X1. So just for people out there who wonder what I'm talking about, at reInvent they announced a new machine. It's the X1, and it has 2 terabytes of RAM and 1,000 cores. It's a beast.
Didn't see the pricing on that.
No, I didn't.
A few tips and tricks. So one of the main things to be aware of is essentially you don't have super privileges on that database.
Right.
So if you are doing really low level, crazy things on the database, you're doing a lot of advanced configuration of the database, it's probably not the service for you. They do limit things like we couldn't install a Python library because of a security reason that they've not allowed it. So you can't SSH onto the instance and start to go to town. So that's worth bearing in mind. But for most people, I mean, that's something you want to avoid.
Yeah. Now, what's the story on the enterprise geodatabase support here?
Right, so Esri support installing their Esri geodatabase on both PostGIS, on top of PostgreSQL, and SQL Server.
Okay.
So they've got very good documentation on their website.
Yeah.
I mean, you can go and install a geodatabase right on top of those two RDS databases.
And it just works.
Robin says she's got it going internally for us.
So that's great. Yeah. That's great. Yeah.
Tried and tested.
Yeah.
And these MySQL, PostGIS, and SQL Server actually have spatial support out of the box on RDS.
Yeah.
Not Oracle Spatial, unfortunately, but the other three, you just install the extensions. There's documentation on it, and I think for SQL Server, it's just there actually.
Okay. And for PostGIS, I remember turning it on. It was like literally one command.
Exactly. Yeah. Did it the other day, so
it's really nice.
It's easy, and then you're off full spatial index support. Okay, so there's been a lot of excitement around AWS Aurora. They talked about that a little bit at this conference as well. It's essentially Amazon's own go at a relational database. So they've said, we're going to build a relational database from scratch using S3, using Dynamo, using all of these underlying technologies, and Aurora is the end result. So it has, what they've essentially done is, if you look on the left, the legacy database architecture is you have the storage, the database engine, caching, logging, everything on one instance. Makes it quite hard to scale. You need read slaves, you need, the data's all there. Aurora, you can see they move the caching and the logging and storage out onto, they've separated it into other services. So what that means is you can scale the SQL engine very, very easily, and your data's persisting on S3 across all of these different regions. The end result is 5 times increased performance compared to MySQL. You can do 6 million inserts a minute, 30 million selects per minute.
Wow.
It's crazy. It automatically repairs failures, crash recovery. It's a hardcore enterprise database.
And I remember the crash recovery was something. So tell us, how, like, if it does crash, how long does it take to recover?
Like, it's a few seconds.
A few seconds.
Built in as well.
It was crazy.
They just throw things away. It's stateless essentially. So why wouldn't you use it? I mean, surely you'd use this. It sounds great. Well, there are a few gotchas and a few things to think about.
Right. And I think the thing is with Aurora, if you need a big database, it's cheap.
Yes.
But if you're just building a prototype and you need a small database, it's expensive because it's only available on large Amazon instances. So that's kind of my takeaway. Exactly. I remember watching, thinking, and they talked about how cheap it was, and that's true if you have a lot of data. But if you're just starting out with a prototype, it's expensive because it's a big instance. So let's say I'm starting small and I want to grow big. So what would you recommend I would start with an RDS then?
I would recommend, if you're going to go to Aurora, you'd start with MySQL.
Okay.
But to be honest, with the power of FME, you could start with Postgres or any of them, and you can rewrite to Aurora. So you can easily move to Aurora when you need to down the line.
And I guess the other thing we found is that Aurora does store spatial data, so no problem, but it doesn't have a spatial index. So depending on your workflow, that may be a problem. The scan speeds were hugely fast just because it's an incredibly fast machine, but for large amounts of data, if you need to do spatial queries, then PostGIS or some other RDS solution, geodatabase or something.
That uses InnoDB storage engine on MySQL, which doesn't support spatial indexes.
So
cross-region replication is also not supported by Aurora, but I mean, I'm sure at some point it will be.
And again, goes back to a region is not one data center. It's a region is multiple data centers that are geographically separated, are not on the same power grid, and there's so that's,
you'll be all right.
You'll be all right.
Okay, so now we're going to start shifting into patterns and the patterns we've experienced over the past few years. What I want to do is just quickly introduce the 4 services we're going to be talking about in addition to S3 and RDS. So the simple queuing service is Amazon's exactly that. It's their internal queuing service, and essentially you put messages in a queue and then you can pull the messages from the queue in a fault-tolerant way. If there's anything to add to that, but it's quite simple really. Very reliable. And you use it to decouple architecture. So you can put a queue between two applications. Rather than calling the application directly, you put the message in SQS, and then the other application pulls from it.
And I believe that SQS was the first service.
Okay, well,
yeah, the very first.
Yeah.
So, and S3 came shortly after. Yeah.
We've been running cloud on it for a few years, and it does go down. In fact, it did the other month, but it's very, very rare.
Yeah.
And it causes chaos when it happens.
It's a fundamental building block of the whole stack, absolutely.
Lambda is their new service out in the last year, and this is very exciting for me. It's their compute service. They just added Python, actually.
So it's a compute service, but you don't actually worry about paying for compute or buying EC2 instances.
No infrastructure again. So all you do is write your code.
Yeah. And then they run it.
And then they run it, and you pay per million per million runs of the method, basically.
Or 100 milliseconds.
Right. 100. Sorry, I think you're right. 100 milliseconds. So.
Which is very small.
It's very small. Essentially, if you're playing around, it's free, and we'll show you that in a minute. Simple notification service is used for sending out notifications.
Or receiving them, that's
receiving them, Apple push, Android push, Microsoft push, all this type of thing, emails. API Gateway is a new service, and that essentially allows you to build a REST API through a graphical user interface.
And I know that that's one that you're really excited about. When Lambda came out, Stuart was really excited. He went in his office, shut the door, came out a few days later, literally with a great demo. And we've actually, he's going to talk about some patterns. And then the other one that Stuart was very excited about was an API gateway, because at SAFE we had talked about something like this.
Yeah.
And then 6 months later, Amazon came out with it, so it's
even better, right?
Yeah, absolutely.
Now we can focus on what we do, and it's amazing. You can build an API in minutes, and we'll show you that. So let's dive into some patterns that we've experienced. So the event-driven design pattern. Really, this is a difficult thing to do on premises. You're going to require a lot of custom development, and what it essentially allows you to do is respond in near real time when data comes in on either Amazon S3, Amazon Kinesis, or Amazon DynamoDB. So we're going to focus on S3, but if Don uploads a file to S3, basically I can subscribe to that bucket and say every single time a file comes in here, send me a message. Very, very powerful.
Yeah, and the nice thing about Amazon S3 is the notification is not sent until the object is complete, which is really nice, because we have notifications on other things in FME, and under the covers we have to make sure that this file is not still being written before we send the notification. But Amazon, again, they look after all that for us.
You don't even think about it.
You don't even think about it.
But it's a very hard problem to solve.
It is, yeah.
So what we're going to look about is hooking up Lambda and FME to the S3 bucket to build some automated processing workflows. This is kind of the pattern that we've seen over the years. Quite a few customers are using this. So data comes in on the left into an S3 bucket. It could be raster data, it could be photos, it could be, it could be whatever.
It could be LiDAR data, whatever.
Exactly, yeah. And then what we do is we hook a Lambda function up, and this Lambda function, all it does is it takes the message in. So every time data is uploaded, the Lambda function is called, and it checks to see if an FME Cloud instance is running. And the FME Cloud instance, it uses the API call, and it says, is the FME Cloud instance running? If the FME Cloud instance isn't running, we launch the FME Cloud instance dynamically using the API. It takes about 2 minutes.
Yeah.
We then put the message into an SQS queue. And the message in the SQS queue basically says, there is data in this inbound S3 bucket, this is the path to it.
Yeah.
So then the FME Cloud instance comes online, it pulls the message from the SQS queue as soon as it comes up, and that's essentially its job queue. And it pulls the data down off S3, processes the data, transforms it, and then puts it back wherever you want it.
And so if other data comes in while the FME Cloud instance is coming up, then they'll just queue up in the SQS queue.
Right.
And so then when the instance comes up, there'll be a whole bunch of jobs in there. It'll process them all.
Yeah, exactly. Yeah. And what do you pay for here? You pay for exactly what you're using. So when the FME Cloud instance isn't processing data, it's shut down.
Yeah.
when you don't have data in the inbound S3 bucket, you're not paying.
Yeah.
So it's a very cost-effective solution.
Yeah, and the cost of Lambda for this is essentially, it is free.
It's free.
Yeah.
Because unless you're uploading huge volumes of data, it's free basically.
Yeah.
So it's a nice little workflow because you don't have to, the only code you write is just code that even I can write, that's just like JavaScript or Python or something, and you don't have to worry about anything.
Yeah.
And then everything else is either in the GUI in FME Workbench, or it's just Amazon doing its thing.
Yeah.
So let's do a quick demo and dive into the danger of the demo. And what we're going to do is we have a workflow where we're going to upload some LiDAR data.
Yeah.
The LiDAR data looks like this. So I'll just have a quick look at it. It's pretty standard, small piece of LiDAR data. And what we're going to do is process this LiDAR data as soon as it's uploaded, and we're going to turn it into a GIF.
Right.
So very, very simple. So what we'll do is go to the S3 Management Console. And the first thing to note is I have this AWS webinar bucket. And if I go on Properties, this is where you configure all of the magic for versioning, lifecycle management, but there's also this events collapsible here. So you can see here I have an event configured, and if we edit that here, I'm going to say when an object's created in this incoming bucket, because you can filter by bucket, which is nice. You could even filter by suffix if you like as well.
Sure.
I want to send a message to a Lambda function.
Okay.
I could also send a message to an SQS queue or an SNS. We could go straight to SQS, but we want to use Lambda just to check if the cloud instance is running.
That's right. So if my cloud instance was always running, then I could send directly to SQS queue.
Exactly.
But this pattern enables me to build a much more cost-effective solution.
Right. So we'll just do actions, upload this last file, and it's about 9 megabytes. It's a smallish file.
Yeah.
Start the upload. While that's uploading, that's fast. What we're going to do is look at the Lambda function. So I'm not going to go into too much detail here. What I just want to show you, let's make this larger, is all we're really doing. This is basically the object that's going to make the API call to FME Cloud. We're checking to see if the instance is running. If the instance isn't running, we invoke, so if it's paused the instance, we invoke another Lambda function here, and we basically launch the FME Cloud instance using that Lambda function.
Perfect.
If the instance is running and it's online, we just send the message to the SQS queue. So that's it. So basically what's happened now, this piece of JavaScript ran, the instance is already running, so the message has now gone into an SQS queue. What happens now is this is our FME Cloud instance running, so I can click here. There's a workspace running on FME server that's watching that SQS queue. If we go on run, it's not very glamorous workspace, but there's a workspace in webinar and demo SQS controller. It's probably best if I show you it in FME actually. Let's have a look at FME. So this is the workspace here. And you can see it has an SQS receiver. We have lots of AWS specific transformers. It basically watches the SQS queue, gets the JSON from the SQS queue, extracts the path to the file in the bucket, and then we use the S3 downloader transformer to pull the LiDAR data down to our cloud instance. We process the data. We're using the job submitter, and the workspace is really simple to turn a LAS into a GIF, if that's it. It's essentially one transformer, raster DM generator.
There you go.
We're basically turning this transformer into a service. And then once we're done, we basically, if the translation was successful, we upload the file back to S3.
To the upload directory this time.
To the outgoing. So
perfect.
What we should be able to do now is look in the outgoing directory. Just have to refresh
that. And there it is.
There it is. So there's a GIF file.
And it's even ran today, Stuart. So there we go. It wasn't smoke. It wasn't smoke and mirrors.
Maybe Claude just dropped it in there.
That's right. We have the Claude pattern.
So that it's a simple workflow, and we hardly had to write any code. And obviously, you can reuse that Lambda function.
Yeah.
Okay, so let's go back to the webinar.
That was strange.
Yeah, I didn't like that.
It didn't like our laughter.
No, it didn't like our jokes.
No.
That's fair enough. Okay, so this is a real customer example.
Yes,
doing
yes.
a similar thing.
And this one's the same pattern, but with one extra twist.
Right.
Yeah.
And just to give you some background, what they were doing is essentially taking satellite data from Europe, and they had 880,000 tiles every 12 hours.
What the heck?
Let's just turn it down a bit.
Okay.
Is that better?
Hopefully.
So we had 880,000 tiles every 12 hours to process,
yeah,
which was about 80 hours of compute time.
Yes.
So what they wanted to do is cluster a large number of FME cloud instances because it's time sensitive, it's weather data.
Right. And with FME Cloud, you pay when the instances are up only.
Exactly.
Yeah.
So it cost about $80 a run.
Yep.
To do this every 12 hours, so about $58,000 annually.
Yep.
On premises, not possible.
Yeah.
I mean,
yeah.
So it's this design pattern, and what they were doing is tiling, web map tiling, which is very compute hungry.
Yeah.
And they launched 5 cloud instances of our largest instances, so we had like 40 engines running.
Yep.
And we did the job in about 3 hours.
Mm-hmm.
Shut them down immediately and waited for the next 12 hours.
Right.
And the end result is that the incoming satellite data is turned into web map tiles.
It's like a worldwide weather processing job. Yeah.
So yeah, it was a good little workflow, and there's a few others that have used this pattern.
Right. And the wrinkle was, on this one, you actually figured out when to shut the instances down, because your other previous pattern, we kind of ignored that.
Yeah.
We showed how to start the thing up. But when the jobs are all done, obviously it's really nice if the system shuts itself down. And in fact, how did you do that on this one?
So we had a workspace running, and it checked to see, using the REST API, to see if there was any jobs running on the engines, so how many engines were free.
Yeah.
And when there were 0 engines running, and 0 jobs in the queue, then we waited a little while, and then if it was still the case, then we shut down.
Perfect.
It worked well.
Yeah.
So, you can talk to us about that offline if you're interested. What we're going to move on to now is data delivery.
Yeah.
And this is kind of the next generation of data delivery, I guess, using Amazon.
Right. And this is where S3 really shines.
Yeah. I mean, build me a better content delivery service than S3. I mean, it's phenomenal.
Yeah.
And we've already kind of been through this, but Amazon has multiple services for storing large volume of data. If you do want, Redshift's a data warehouse. We could just mention that briefly. So if you have petabytes of data and you want to do some kind of business analysis, kind of like ask questions of the data, then you would basically use Redshift. But Redshift's built on S3 anyway.
Yeah.
You have to put your data in S3 to use Redshift. So similar. The costs grow with the popularity of your data service, and you build the workflow. So there's a few patterns we've seen here as well. So one of them is essentially using S3 as a massive cache.
Yeah.
So you have your data in a legacy database.
Yeah.
You have some in Salesforce. You have some in S3.
Yeah. And this works for on-premise or in the cloud. So if my legacy database is on-premise, I can use this, or if it's in the cloud, I can use this.
We can connect securely on-premises.
Yeah.
So what we're essentially doing is using FME Cloud as a scheduled bulk export. So every 6 hours, you read data from all of these different services. You read it from wherever you want. You consolidate it, and you put it up on S3 as, I don't know, imagery, Excel, PDF, JSON, whatever.
Yeah.
There's things.
If I put an HTML file on S3, then does it render in my browser as a web page?
It would, if you configured the bucket. So you could do that, and you could build websites on the fly.
And we've done that with FME Cloud as well.
Right. Yeah. And then if you're on the Rolls-Royce, then sit CloudFront on top.
Yeah, if you need to even further performance turbocharge it, then yeah.
And that would be good if you were serving huge volumes of raster data.
Sure. And it's so cheap; it's almost a best practice anyway.
It's easy to do.
And it's easy, exactly.
So this is good. This is good if you want to basically provide a big caching layer on top of FME. I'll say it's near real time.
So question, let's say I had an on-premise web service. Could I use CloudFront directly on top of my on-premise web server?
Yeah, I think you can, but I think you go through VPC or you need some
you need to set up VPC.
Yeah.
Okay.
Yeah, exactly.
It is possible.
Use it. It's not just S3, I believe. Yeah,
Okay.
you can use your own web servers.
Okay.
Claude could double check with that, maybe.
Okay.
So the next, this is out. It's as real time as you want to schedule it, basically.
Yeah.
The next thing we're going to look at is real time data delivery. So this is, Dom makes a request for some data. We go get the data out of the database.
Yeah.
We go get the data out of Salesforce or ArcGIS Online, wherever the data is. We might mash it together, we might transform it, and then we deliver that data to the user directly via email, or even they wait in the browser for a return.
Right.
This is kind of our classic
data
download, but it's good on the cloud because, again, here you're not worrying about any infrastructure, basically. And you know, as more and more data moves to the cloud, it makes sense to have FME Cloud, FME Server up there as well.
Yeah. If your data's in the cloud, then FME Cloud is really the way to go.
Exactly. Yeah. Okay, so this is the state of Arkansas's data portal. So these guys, they use one of our first FME Cloud customers, and they built a data portal. And this is really what we were just talking about. They're doing real-time extraction from their PostGIS database. And they also, this is a nice touch, you can go through FME Cloud to do the extraction of raster data. But because S3, everything's file addressable, you'll notice in the bottom there you can do a direct download of the entire state as well.
Wow.
And of course all of the load
is completely off the web server.
Right.
Yeah.
And another nice tip these guys did, if you have a lot of raster data, put your raster data on S3 and then use FME to create footprints of that raster data into vector data. You can use the bounding box accumulator. So then you have a massive PostGIS vector database table of all the raster footprints. And you can put the URL to the raster file in the database table. So then you just query the PostGIS table and say, I want all the raster in this area. And then you just get the URL and download it and give it to the user.
Perfect.
Very, very good way of performant S3, raster extraction, basically.
And so, so the cost, this was what really sold it for them.
Yeah, this is from them.
So, just because they sent us this spreadsheet, so we didn't ask for it even. They just said, hey, here's what we, And you can see, I mean, things have got less complicated to start with. There's fewer things.
You can look at the cost saving there yourself.
And what cost is missing? What they're assuming a cost here is the same in both.
Right, it's our friends in IT.
And again, we know that to keep on-premise data centers running, they just don't run themselves. There's so many things, so.
Exactly,
But again, that wasn't even considered.
Too hard to cost.
That's right.
Basically.
So,
And these guys own it now, though. That's the thing. They control it. They own everything.
And so what they're doing is they're just, of course, they're smart guys. They're just redeploying those IT resources to do higher value things. So,
And ouch, their rack space costs were $3,200. That was just for the space on the floor.
Crazy.
So what I want to talk about now is kind of what I see as the next generation of data delivery. And APIs have been a buzzword for years. In fact, I think Amazon wouldn't be here without APIs.
That's right.
They've disrupted entire sectors from Salesforce to Amazon through
databases.
Exactly. With just APIs are everywhere. But I'm not really. Obviously, APIs provide value there, but those guys, they can afford a dev team. They can build a Node app or a Rails app and build a nice API. That's fine. What I'm talking about is a small guy who wants to build an API on top of a legacy database. He wants to build an API that's going to last 4 months on top of a project. I see huge value in being able to do that, because if you have a legacy database, how do you provide access for a developer to that database? You can use FME Server, it works well. Other than that, let them execute SQL. So what I want to show you is how you can basically create a nice API on top of any legacy data source or data set.
Yeah.
So it looks something like this. You use the API gateway to define the API. So this is my example. We're going to build a transit API. So we have a buses database table, and we want to let developers get all of the buses, the current location. We want them to be able to get a specific bus, and we want the bus to be able to update its location via the API. So how would you do this? Usually in the past you'd write code on top of the database to create a REST API. What we're doing now is we have three layers. The API gateway to define the API. FME Cloud is where all the business logic lies.
That's right. So it implements the API.
Exactly. This is I'm going to take the data from the database and turn it into JSON that the API gateway is then going to deliver. I'm going to use the SQL executor transformer to update the database. Works really, really well. So this is essentially what it looks like in a little bit more detail. And now we'll try and dive into a demo. So if I move over to the screen. So the first thing is we've got a web map application, and that's just reading the locations of the buses. So you can see at the moment the buses are all in the terminus. They're in Vancouver, sat there.
Yeah.
So we have, if we go to the back of the stack, let's go right to the back. We have this database table in PostGIS.
Yeah.
It has 4 columns. One is the bus number.
Yeah.
That's the ID. One is the route number.
Yeah.
And then the direction, and then the geometry, which is the location.
Yeah.
So we want to build an API on top of this database table. So the first thing, if we step back, the next thing we need to do is build the extraction logic on top of this database. So to do this, we use FME. So let me just open the workspace. So we can look at the get all buses workspace to start with. Pretty simple.
Pretty simple.
But not that easy to do in code.
No.
So you're reading the RDS buses database table and you're writing that out to GeoJSON.
Yeah.
You know, that's it.
Yeah.
That's what was powering. When I click refresh in the web map, this was running.
Yeah.
The next one is a little bit more complicated, and this will be a lot more code. So what this is doing is this is our update logic.
Yeah.
So this is imagine the buses has an Internet of Things device that's posting to an API to update its location. So what we essentially do is we have parameters that you can provide as input for this workspace. So you can set the bus number, you can pass the route number in, the X, Y, and the north direction.
Yeah.
So if I was to run this workspace, it would basically test to see if these values have been set, and then use the SQL executor to update the database.
Yeah.
Nice and simple. If you're a big fan of FME, it's easy to use.
Yeah.
So what we need to do now is turn this into a service, essentially.
Yeah.
So what we do is we publish this up to FME server. So I won't go through this process, but essentially what we do is we'll have a look at it on FME server. We take this workspace, we push it up to FME server, and we essentially create a service out of this workspace. So if I go run here, and we go in webinar, and we go in update buses. So these are my parameters. So bus number, route number, direction, X, Y. So we could stop here now.
Yep.
There's good value here. You can basically now run this via a web service, which is great. You don't need any workspace knowledge. But look, this interface is nice.
No, and it's how are you going to call that programmatically?
Right. And what happens if I already have a massive API?
Yeah.
And I want to integrate this as part of that call?
Yeah.
Or what if I want a rate limiting, I want threshold, I want security. That's what API Gateway gives us. So what we can do, if we go down here, is we can see here, this is accessible via a URL.
Yeah.
So we can take this URL into the API Gateway,
yeah.
and it's essentially a proxy that's going to call it, and it's just a nice interface.
Yeah. Yeah.
So let's now move a step forward to the front and go to the API Gateway. And we have 3 APIs here. This one is the one we're using today, Transit API. So this is where you design your API. This is all Amazon.
Yeah.
Make this a little bit bigger. So you can see here I have 2 calls, the get call and the put call. So let's just make an API call. I'll show you how easy it is. So I'm going to create a resource, and let's say we have a new one called trains. So this is just to show you. So we're going to create a resource, and now you have a trains endpoint in this API. What you do now is you create a method.
Give it a name.
So I'm going to, this is a get, let's say a get method.
There you go.
Against this call. Click tick. And now what it's saying is, okay, which
implements it.
Exactly. What do you want to call in the background? And look here, you can call a Lambda function.
Yeah.
But we want to call HTTP, and we would call FME server directly here like this. Obviously, this is for trains. It's just an example. But you can see the idea.
And then the HTTP method would be get, would it?
Correct. Yeah. Sorry. Yeah. So we do that, and we save that, and then once we have that, what it's saying in this interface is, okay, you've got your front-end implementation of the API, but you need to map it to the back end. So this is what the method requests and the integration requests are.
Oh, okay.
This is a little bit more complex to explain, but let's walk through the put. So this is going to do the update. So if we look in the method request, this is what we designed the API to look like. A nicely designed API. So direction, route number, XY, response, these map quite well to the parameters that we have here. But imagine if you had an old legacy database or something. So, you know, these are the ones, these are what we're going to expose. And then this is where you map it to the FME server parameters. So the URL query string parameters. So here, response that we've defined in the API is mapping to opt_response format. Well, I'm kind of glad we're not exposing that. I think response is a better end user experience. And so now we have that mapping. We'll just delete this resource. We can deploy the API. So what this essentially allows us to do is, again, this is where Amazon strength come in. We could have V1, V2, V3. We could start to manage our APIs. We're just going to deploy to staging. And you see now, look, it's given me a URL.
Now, can you generate a vanity URL?
Right. So you could use Route 53 to build whatever. dons@greatapi.com/transit. But look what we've got now in here. So we've got, do you want to enable an API cache? Do you want to do in-depth cloud watch monitoring? Burst limit, rate limiting.
That's fantastic.
Upload a certificate. And do you want to create an SDK for Android, iOS, or JavaScript just by a click of a button?
So if I set a burst limit and calls come in quicker, then would that trigger a cloud watch? Is that the idea?
It triggers a cloud, and it gives the user a good end user experience. You've gone, I think it gives them some kind of HTTP response code error. So you've basically gone over your.
Fantastic.
It's all configurable. So
fantastic.
If I hit this API now, this is the API call. This is the get. You can see it quite fast. That hit the database.
And for something like that, I mean, the caching can be huge.
Exactly.
You know.
You
know, I'm thinking if using this for something like WFS or anything where you want to have caching, this just does it for you.
It's incredible, and it's only been out for 2 months. It's got a long way to go. So now let's do an update. So this is getting a little bit more technical.
Cost on this?
It's cheap. They basically want you to use Lambda.
Okay.
And I think it does have a cost, but if you look here, the cost is around it's storage, so the cache storage and CloudWatch costs you money.
And probably millions of requests per hour or day or whatever. They're
going for the big fish. So let's go and just update the database. So this is a little bit complex, but this essentially allows you to run an API call in the browser. So we're just going to pass in an updated XY. And so let's send that. And that's using the put option. If you see there, we're doing a put against this. So success. So I should be able to come in here now, update this. This is doing the GET request, so we can see the bus has moved. But look how fast it was. I mean, that was using FME. That ran that workspace. It ran this workspace. There was no caching, so it's very fast.
Very fast.
And if something had failed on FME's end, we would have known about it. So there's fault tolerance built in there.
Fantastic.
So I'll stop going on about this now.
No, it's fantastic. It's a game changer for sure.
It's definitely a big deal.
And
I think I'll be wanting to explore some more, you know, maybe not webinar, but certainly technical sessions around it.
Yeah.
So yeah, please ask questions if you have any questions on that.
Yeah, it's a game changer. So.
Okay.
Yeah, so free training. Stuart and I will stick around after this to answer some questions. But at SAFE we have free training. It's instructor-led training. So the way we run this actually is with Amazon. Right. We actually set up EC2 instances for you, so you have your own machine in the cloud. So you simply log on to that machine. We run through exercises. It is instructor-led, so you have somebody to ask questions to. So that's November 17th and 18th. Mm-hmm. And then we have another one on FME server authoring, and that's December 1st and 2nd. So there's the URL there if you want to give it a try.
Yeah, they're great.
Yeah,
they're really great. And this was kind of a last-minute thing, but I think it's a great idea.
Yeah.
So yeah, we're planning on doing a doctor's office in the future. So yeah. What's that look like?
Yeah, so basically it'll be, we essentially set up a Google Hangouts on air, yep. And we'll have our AWS experts, so there'll be probably Stuart, Pascal, Claude. Yep. I'll be there just because, you know, I like hanging out with these cool guys, and it's a lot of fun. So, and come and ask anything about AWS, and we'll be sure to send this out to everybody who registered for this webinar.
Go away, have a play, and come back with your questions.
Yeah. And if you want to try FME, desktop, server, cloud, just contact us. Go to our website, and we have free evaluations. Try them for, you know, however you need to, and we're always here to help.
Yeah, definitely. Okay, so
we finished a great time. Look at that. We're actually 5 minutes. We're right on for questions.
Okay, so yeah, when will we get spatial support in Aurora?
That is an Amazon question.
Yeah.
Right now, FME can read and write spatial data into Aurora. So Aurora does support spatial data as far as reading and writing. There's just no spatial index. So, you know, that Amazon is aware of that. But we haven't heard, and of course, we have no idea. Yeah.
Right. In the inbound S3 bucket, can it be emptied basically after the upload? So the answer is yes. Amazon has an API for everything.
Yeah, and we have our S3 deleter too.
Yeah, and we have an S3 deleter transformer, so you definitely do that. Can you give some examples of data processing? Well, I mean, it depends what you're doing. Like we showed the LiDAR one.
Sure, if it's raster, you could reproject raster. You could resample raster. QA is a good one. Quality assurance, not questions and answers. So we have a quite large number of clients who have set up. They have people out in the field, or even within an organization who submit data. They have a quality assurance process. It can be on attributes or geometry that's run, and then gives a user feedback immediately on if the data that they're building meets spec. So, but we have within SAFE, we've used FME Cloud for many things, like even integrating Salesforce with Slack and our bug system with Slack.
Yeah.
And so there's just you know, of all the things that of all the different things we connect, it just boggles the mind. There's so many different things.
3D as well.
Yeah, 3D. I mean, some people have built workflows that generate Minecraft worlds from 3D data. So, and that one's been a huge hit in the Scandinavian countries where they have gone Minecraft crazy. Mm-hmm. And so there's just so many different things. You know, like comparing LiDAR scans to CAD models to see if, as buildings are being built, they actually match the CAD drawing. So that's another thing people are doing. It's just, XML, of course, and GML. Nobody can have a webinar without talking about XML and GML. These are, you know, XML is a standard way of sharing data, and GML is, people in Europe know, is open standard for storing spatial data. So, yeah.
I think one of the other things as well is there's a few questions here about, oh, I love all this stuff, I'm waiting to move to the cloud.
Yeah.
So, you know, we've successfully taught, if you think you can't move infrastructure to the cloud, we're happy to talk to you, because we have security white papers, we have a lot of experience with how we've secured the cloud. So, you know, we've persuaded certain people before to give them confidence in it. So.
and many people, even on premise, have used it for prototypes. So we have many cases where there was a prototype, and that was built using the cloud, because again, now you can build a prototype in the cloud. The FME cloud is outside your corporate infrastructure, so you don't have to talk to IT about opening firewalls and all this. You can build it at very low cost, and then what's often happened is that's either been shown and then it's been brought in on-premise deployment, or has been a great sort of catalyst to help the organization move to the cloud.
Exactly, yeah.
So the interesting thing about the cloud in general is and it's been existed on the desktop. Like Dale and I started SAFE, we're two guys in our back room being able to build a desktop application. But there's no way in the old days we could have built a scalable web application, because you just didn't have the resources, the data center. What cloud technology does is allows anybody with a very limited budget and a great idea to start at very low cost, and then if the solution takes off, Amazon looks after the scaling, right?
Yeah.
There's nothing worse than having to buy a big data center or spend a lot of money on hardware only to find out that your solution isn't successful, or the other's just as bad, maybe worse. You start off thinking small and it goes crazy,
Yeah.
and now you can't scale up. So the cloud is a game changer for the building of these web-based solutions, really.
Yeah, it allows you to be a lot more agile and take more risks, which is, at the end of the day, good for business.
Yeah.
Lots of innovation coming out of that.
Yeah.
So I think that, do you have any free training combining FME and AWS? Not specific AWS, but I am going to spend a lot of time over the next 6 months to a year just creating AWS content. We've got Kinesis transformers coming.
Yeah.
We're going to be looking at the Internet of Things announcement from Amazon to work out how FME can tie in. Yeah. So there's going to be a lot of content coming out, if not necessarily training. Maybe we'll do training.
Yeah, just go to our website. Just go to our front page of our website. Yeah, so please do, if you have things specifically you would like us to do for training with FME Cloud and AWS, let us know. The reason I had it brought up is in the bottom right corner there, you can see our live chat. And we are online, and anytime you want to reach out to us, maybe you're trying FME, maybe just have a question, literally just type there, and we have people who just live for your questions, and it's connected throughout the entire organization at SAFE, from our support team to our developers to Dale to myself to Stuart, and we're all watching that. So that is a great way of reaching us at SAFE.
Yeah.
So.
Okay.
Wow, Stuart, that was fun.
Yeah,
so any other questions? Or I see some. We apologize for the sound issues. That was our internet, and you know it's the old demo thing, right? Your internet's stable until you're doing a demo or you're doing a webinar, and then there's glitches. But fortunately, it came back. I have been on others where it never did come back.
The Wi-Fi saved us.
That's a first. That's a first. Yeah.
Yeah, I think that's generally about it for questions. So.
Yeah, and thank you for attending with us today. We're obviously pretty excited about FME Cloud, AWS services, and we're at SAFE we're continuing to invest in that. We see that as the future. Well, we see it as today, but it's only going to grow in the future. And it's very, very exciting times at SAFE and in the industry in general. So
Yes.
So, and thanks to Claude for being in the background there. He's one of the brainchilds of this with Stuart and Pascal, so of FME. So they've done a great job. So thanks, guys.
Great. Thanks a lot.
Yeah.
Bye-bye.
Bye-bye.